good day, good morning, good afternoon, good evening, wherever you're in the world. Welcome to another special section of Office Hour by UrBizEdge. So we're having a special guest by the name Ifeanyi Benedict. He'll be taking us on the topic building a simple ML model. So let's talk about the company that you brought this program, UrBizEdge. UrBizEdge is a registered Microsoft Excel consulting, financial modeling, business intelligence, data analyst, and enterprise solution firm in Nigeria. We specialize in helping company and high-value professionals be on top of the business data. So this is a calendar of our upcoming training. So most of you might not know, UrBizEdge is also a training institution also. So this is calendar for our upcoming training. The next training we'll be having is on the 24th to 25th of January, which is financial statement for non-finance manager. We also have another one coming up on the 28th to 29th of January, which is in-depth Excel training, executive dashboard, and business data analysis. Also for February, we have on the 4th to 5th of February, we have in-depth Excel training, executive dashboard, and business data analysis. So our speaker for today is Ifeanyi Benedict. As already said, these are some of his profiles. So Ifeanyi Benedict is a data analyst and trainer with UrBizEdge. He's skilled in Power BI, Microsoft Excel, and Python. His passion lies in helping you get the most of your data and community building. Benedict is also a technical writer and a content creator. So if you check some of our YouTube channel for UrBizEdge, you'll see some of his articles and also our UrBizEdge blog. So you can follow Benedict on LinkedIn with Ifeanyi Iheagwara. I'm not really good at pronouncing his surname. And also you can follow him on Twitter with Benny Kalius. So without further ado, I'll hand over the section to Ifeanyi. So Ifeanyi, over to you.
Hello, everyone. Hello. So today we're talking about how to build a simple ML model. So I'll share my screen. Okay, right. So you can open up your Jupyter notebook, or you can any idiom of your choice. So you can use Data Collab or you can use Jupyter. So I'll start. So today I'll just be giving a brief overview of machine learning. That's more of an intro into machine learning. Okay, so first of all, what's ML? ML is machine learning, and it's a subdivision of AI, artificial intelligence. So ML is basically your study of the computer algorithm to improve upon the learning. So you're teaching your computer algorithm. By algorithm, I mean your software codes of a model. So you're trying to teach it so that it can learn and it can do a task for you. So how do you do it? So error is basically takes place of three basic things that takes place. So you're trying to at first like predict something, maybe the prices of a house, to predict if someone has cancer or not. So you're trying to make a prediction. Also again, it also has it also has the error and loss part of it, and again the training and learning, like the name says, machine learning. So you have to train the model, and you have to train the model, and you have to train the model or learn. So you can either call it training or you call it learning. You pick. So the process of ML is. So let me just give an example first of all. So let's take a guessing game. So by the guessing game, you make a prediction. So you are told to maybe make a guess. You make a guess. That's kind of similar to making your prediction. And then when you make the press, maybe they show you the correct card and you got it wrong. So you kind of learn to say how right or how wrong you were, which is the error loss phase of it. Then the training is then you learn from your mistake and you try to get better at making better prediction. That's just a simplified way of explaining the entire process. So the process takes place under four basic principles. So first of all, you are trying to pre-train your model using data. So to cheat the model, you have to present it with data. If it's already labeled or unlabeled, depends on the type of ML model you're trying to build. So you can present it with data that is already labeled. So you give it a spreadsheet with maybe different features about your houses. So houses may be in Lagos. Some of the current list, do you have a 2-bedroom flat? Is it a 3-bedroom flat? You also have to give it to me by the end, and you also again the price of all these individual houses, which is the training or pre-training your model using data. Then you give it an algorithm to train your model. By giving the algorithm to train your model, there are different kind of algorithm. We'll go further into that. So you say that you're trying to do a linear regression or a classification or something. Then you pre-train the model. So after you make model, it makes a prediction. The model makes a prediction based on the training it has already gotten with the already established data it already has. And then it's maybe you find out that the prediction wasn't so good, and so you pre-train it now with maybe more data, or you add more features, or you got your gradient descent or something to improve on your model. Okay, so I mentioned some different words here, like I keep mentioning model. I know. So model does basically means your algorithm, which I mentioned it means is block of codes of block, which is like simply like block of codes. So your model is basically the algorithm plus the pattern which the machine like learns upon, and the data you're going to give it is going to have some particular features. So when we say features, we mean characteristics. So now you're trying to predict the prices of houses in Lagos, and for you to predict, so all these are determined based on there are some parameters that either that you can't just say your house is what it is. There are some things, so maybe the location of the house that influences the price of the house. How many bedrooms does the house have? How many toilets? How many bathrooms? Does it have a parking space? So all that, those are your features. So features basically just means the characteristics of the house. And the algorithm is going to be, depends on what you're trying to find. So now we're trying to find the prices of the house. So we'll go more with a linear regression. If we're trying to find out does someone else cancer or not, so that's more of a classification model we're trying to build. Okay, so features could also again be, they could be categorical or they could be numerical. By categorical, I mean, okay, so do you have cancer? Is it that yes or no? There's no middle ground to that. So it's a category, or we're trying to classify balls. So there are different kind of balls. You're trying to find, is it blue? Is it green? Is it black? Yeah. Then numericals, like the example of the price of the houses. You're trying to, so the numbers could be infinite. There's a large range of numbers which could be the price of the house. That's the numeric. Those are examples of like, so that's like a numerical feature. So does have a 3-bedroom flat? That's 3, 2, 4. Those are numerical features. Okay. So and then again, your data. So you give it a data just like an Excel spreadsheet. Today we're using the housing data, which is here. Okay. So using the housing data. Okay, on cargo. Then okay, so this the data set. So let me just open the data set so you get a view of how it looks like. Okay, let's close this. Oh, okay. Okay, so you're trying to predict now the prices of the houses. And so each row represents a house in the data set we're going to give it, and each column represents your features. And in part of the data says we're building a simple model. So you also have currently also have the prices of the current houses of the current houses in our data sets. Okay. Okay, so machine learning models, there are 3 different types. Instead of you're trying to build a supervised, it could be supervised learning you're trying to undergo, or unsupervised learning, or reinforcement learning. By supervised learning, I mean you're going to train it with data, with already labeled data, just like what we're trying to do. So we already know the current prices of ours. So I've given it our features, we're giving the current prices, and we'll train it and we'll see if it can get it correctly. And if we can get that correctly, we'll give it more data to see if we can use the knowledge it has from this already labeled data to get the correct prices of these houses that we don't know yet the prices. Then the unsupervised learning, you're going to give it more of like unlabeled data, and the machine uses on its own a lens to classify or to get a prediction for it. So you give it data that's not labeled. So like maybe we just give it data without, we don't really label. So we'll give it maybe different roles. How we don't get them into different categories, and we'll give it the model, and on its own it has to learn whether on its own it has to learn whether he has to learn how he's going to classify the different data sets. Then reinforcement learning is more of and a very interesting part of machine learning. In this part, the computer takes a step, and based on the goal you gave it, and you're going to train it based on a reward and punishment form of learning. So this is like, okay, like a game. So a game of chess. You give the computer, you build the model, and you give it does learn to learn a game. So the computer on its own has to learn the rule of the games, and from there it learns. So it plays, and it learns you should have done this and all this, and and the computer basically does all the learning on its own. That's it. So the supervised learning is what we're going to do today. Supervised learning, there are either two types: the regression and the classification. The regression, you're trying to determine a number. Like in our case, the prices of houses. So it's just an infinite number. The classification, you're trying the model to group your data into different classes. Like the case I made about the cancer, do you have cancer, do you not have cancer? Okay. So linear regression is this linear regression, this entire formula. Okay, so the y is this is your dependent variable, or in our case, this is going to be the price of the house. What we're trying to predict, we're trying to predict the prices of houses. So this is going to be our y. So this is our y variable or dependent variable. The x variable, these are your features. In our case, these are going to be how many bathrooms, how many toilets, is there a parking space, what's the location. These are features. So the characteristics of your data, the things that you feel that influences the prices of houses are your x or independent variables. That's the x. Then now the B2 or the B1, sorry. B1 is your coefficients. So it's not, most of the time it's not, your features are not just directly coefficients to the prices. You can't say because it has a 3-bedroom flat, so it's going to be this price. So it could be like it's not directly proportional to the prices. So maybe there's a certain degree. Just how much does this affect the y? That's more of the idea of a coefficient. Then the B0 or BO is your constant. This is like the baseline. If you draw, like your okay, so that's this the where the line joins meets here. This is like the basic. So when you don't know anything, or that's more of like, okay, so you ask somebody what's the average price of a house in Lagos. That's a B. That's a constant. That's like the baseline of the data set. That's what your B is. Or you're trying to do for maybe jobs and salary. So somebody just left school. You don't really know the person's years of experience or certification on this. So it's more of like you can say that's similar to the minimum wage. So this is like the baseline. Does not how low this the lowest of that was the baseline of the model. That's a B, that's a constant. So basically what your machine learning model is doing, or algorithm is doing, is using your features and the coefficients to make prediction. Okay, so are there any questions or was everything understood? Because after this, want to move into do a bit of coding to see how we can predict the price of our houses.
So there's no question so far. But if anyone has any question, can put it on the chat box.
Okay. Yeah, earlier I noticed somebody was trying to, I don't know, request sharing the screen. Right. Okay, so like I mentioned, we're going to be using the housing data set, which is for Kaggle. So it just hosts a lot of data set which you can check out. Okay, so the first thing we have to do is we have to import all our libraries we're going to use. So first we're going to import. Okay, so first of all, you can open a fresh IDM or you can use Google Colab. Or you can use an IDM. Yeah. So you guys Jupyter notebook. So first of all, you import all your libraries. So we're going to import Panda as PD. We'll also import NumPy as NP. And we're going to import Matplots for visualization. And find the percentage. Okay, so that's our visualization will show in our notebook. Okay, so when we're done importing the library now, we have to read our data sets. Okay, so we can also look at how the data set looks like using the dotted. So this, okay. So next thing we can do, we can do a bit of visualization just to get a feel of the data sets. Yes, you get the plots. Okay, so this just shows us all our features, and we can see a visual representation of all of them and how much they affect each other. Then we'll do the df.column. So I want to get a list of all my columns. Okay. Then another stuff you can also do is to find the data types of what you're listening. Okay. So for this particular session, I'm going to remove all my object data types. So normally, I'm not going to typically remove them. You're going to have to do some label coding to transform all these objects on data types into a numerical data type by using a label encoder. But just for this session, I'm going to just remove them. So let me get all the categorical columns and drop them all. So the dot drop is just so that I can. So all I did is just I want to see if any of them has data type objects like the main roads, the guest house. I want to drop all of them. So I'm dropping all of these. Yeah, now let me show you how it's going to look like. Okay, so I've dropped all these columns. So you can't see the main road, you can't see the guest house anymore, you can't see the baseline, you can't see this, you can't see this. So I've dropped all that. Let me check if there's any missing data. Okay, so there's no missing data also again in the data sets. Okay, so just like I mentioned, so the next thing after you have done all this, now we have to split, we have to like indicate what are going to be our y and what's going to be our x. So what's our features and what are we trying to predict? So this is going to represent our, so our x is going to be, so this our x, like I mentioned, is just our features. Is everything that we feel affects the prices of houses. Then our y is going to be what we're trying to predict. In this case, that's the price. To predict, which I also mentioned is also the dependent variable. So what I'm trying to predict. Okay. So now you have this. So if you recall, I made sure that now we have to pre-train our model using the data. So we have our data set now, and now we need to predict our model. So we need to make the algorithm like learn the model. So we're going to split the data now into 4 using the train test splits, and we're going to like split them into X to get the training, to get our testing data. So we're going to use our training data to train the model. Our test data, we're going to use that to test the model and see how well it learns. So we're going to train it with the training model, and then we're going to test it on the results to see how well our model is actually doing. So you can use this. You have to import that library from sklearn. Yeah, I think it is. Okay, yeah. Okay. So now we're going to do our xtrain. So this is what we're going to use to, this is our feature. So we have split our feature now into the training and text, and we're going to do this one for our. So splitting the x and y. So give it. So we have to specify how much we want to split it. Either so can use maybe 0.2. So that means we're saying 20% of our data should be left for testing, and the remaining 80% should be left for training the model. You can also include a random number so that maybe to specify how you want it to be. You want to randomize the splitting. Okay, you missed an I. So now that we've done this, we have to now have to use our algorithm to train the model. In this case, we're trying to do a linear regression. Okay, so again from sklearn dot linear model or linear regression. Okay. Then we put a linear regression in a variable, which I'm calling model. And now we have to fit it. So fitting it does basically means training or the process of learning. So we're going to give it the training data. So you can learn the training data now. Okay, so it's going to do that. Okay. So basically that's all so far. So now that we've done this, let's try. Let me see if I can show you the coefficients. Let's say how much the foolish model affect, or that's how much how much the machine thinks the features are being affected by. So we can use that by getting the coefficient. Is the model dot elicit to make it maybe in a more readable. To the column of X, let me skip this in a different column. Okay. So according to our model, we feel it's trying to tell us that one unit of our area will give us a 328.
Hello. Fine.
Okay. What was the last thing you saw? Hello.
This way you are. This way you are. This way you are right. You talk about the coefficients.
Okay, so the coefficient, like I mentioned, is just like how much does our feature affect the prices. That's the coefficient. So it's telling us that a one unit increase in the area or every 1 unit increase in the bathroom affects the prices this much. Of course, our model is not going to be so correct because I threw away a lot of the features. So when we start doing our metrics, you see how very wrong our model is. Then again, next thing I'll show you now is the intercept. So the intercept is as this. So that's like the constant or the baseline. So this like the average or the baseline of the price. So this is like the lowest of prices you can get a house in this place. Okay, so it's telling me this. Like I mentioned, our model is going to be very wrong because of all the features that I discarded. Okay, so now let's make some predictions. So let's make some predictions. Okay, so to make the predictions, so I want to predict now a model using the trading data. We're going to use the string to predict our model. So we're going to do predictions equals to our model plus predict x test. Okay, so now let's visualize our prediction using the white test now. Okay, so as you can see, our model is very, very far from our prediction. Like everything is just scattered and all over the place. And this because we discarded a lot of the models and stuff, labeling and coding them. Even if I do a Instagram to show it, just to see how of our model is. Okay, so now we can use our matrix to gauge like how good or wrong our model is. So this could be our matrix. Okay, so for the matrix, there are different ways you can find it. So you can either use the mean absolute error. So the mean absolute error is just the measure of our absolute error over the predicted error. Just want to see how far off they are. So this is the mean absolute error. Another metric we're going to use again is the mean square error, which is just how close our line is to our data point. We can already say our line is very far from our data point in this. So the mean square error. And the last metric we're going to be using is the root mean square error, which is just the square root of our mean square error. So it's like the standard deviation of the square of our mean square error. Yeah, let's start. So we have to import again this also again from sklearn. Import matrix. Then now I want to do the mean square error. So the mean absolute error. So this is it. And our mean square error. You have to be personalize your spellings. If spelling is wrong, it's not going to be able to call up that variable. Then the mean square error. So please use NP. Then we have to make a square. Like I mentioned, it's just the square root of your mean square root. So release it. So the last thing we can do, so our model is very, very wrong. To improve our model, we can make some adjustments to maybe the percentage we added. We could feed it more data, or we can actually use a graded descent. So a graded descent will kind of like gauge, and we'll be trying it on, we'll split it more and try it more on more splits. We can also we can also save our predictions. In our case, we'll save our predictions. Predict. CSV. Once it's in a CSV file. What do you want to call the file? Let's call it. Come on. CSV. Okay, so this application. So all the warehouses and this what made prediction for sure. Okay. Are there so far any questions? Hello.
So, any question from there so far? I don't see any questions so far. So any question, you can always drop your question in the chat box if you have any questions so far. Any question. Okay, Benedict.
Yes.
So I have a question myself. So, what about those places now you drop those columns?
Yes.
What about if you
Yes.
do something like a
Yes. So
yeah.
that's what I was saying. So I'm not supposed to drop them. Like
Okay.
dropping them has reduced the number of
accuracy.
variables. Yeah, no, yeah, great. I mean, it's actually very bad. So the more features you have, the more features you use to some extent, however, of your model you use, the better it's able to make predictions.
Okay.
So I would have used a label encoder.
The label encoder, yeah.
Yes, to encode this thing, binary preprocessing and use a label encoder to encode our numerical features. But I didn't really do that. Okay, so the significance of the matrix.
Okay, someone's asking what are the significance of the metrics? That's Lawal Beep.
Yeah, okay, so the significance of the matrix, like I mentioned, the mean absolute error. The mean absolute error it tells you the measure of our, like the absolutes in this case, which is like the data set over our prediction error. So what our errors right now is a bit very, very large compared to, and again, the mean square error tells us how close our line is to the data points. I visualized it here, and you can see that our points are very far from our lines. They are scattered. And to improve this model, I shouldn't have dropped this. But I just said I'm dropping it because I don't want to do all the whole label coding and everything. So I should have dropped this category because this shouldn't have happened. Again, you can also use a graded descent, or maybe if I increased even again the size, the testing of the size, maybe if I made it a tree and I split it, maybe it would have also been a bit better. Or I will add a random number. So
Okay, Rashid is asking how can he get the data set?
okay, so data set is available on Kaggle. Let me.
I think I've sent it.
Yeah.
Okay, Inka has to be unmuted.
Okay, so this is a data sent link.
So Inka, you can speak now.
Yes. So this sent it.
Hi, good afternoon.
Yeah, good afternoon.
I'm having headache now. I just joined and I'm deeply heartbroken that I've missed a lot. First, is the presentation recorded so that we can have an access
Yes.
to it later?
Yes.
Recorded
So
on YouTube.
I'll send you the link now for recording. So you could just check here by tomorrow morning, our YouTube channel by tomorrow morning.
Okay, yes.
Tomorrow morning.
It's available on YouTube.
By afternoon, it's also available on YouTube anytime.
Okay, okay. I wouldn't mind if I get a personal contact of yours so that I can message you later. I have tons of stuff to chat to you about, please. Hello?
Yeah. Oh, Timidayo.
Yeah, I've heard you.
All right, thank you.
Okay. So somebody else also asked again. Yeah, the recording will be available on YouTube. Just on YouTube by afternoon you'll get the recording. Okay, so the purpose of a regression is not to say your attribute has more predictive power. To know the predictive power of your attributes, I think it's go to more of the config. Config tells you like how much influence each of your features have on it. So from here, our highest, the one that has highest influence looks like, yeah, I think also is gonna over the bathroom. Also this, yeah, looks like the bathroom has more influence according to this data set. Terrible. The purpose of the regression is more of under supervised learning, which supervised learning is more for regression, and supervised learning that too, basically regression or classification. So the regression is just you're trying to determine an infinite number. Yeah, we're trying to determine prices. The price could be anything. It could be 200. It could be as much as 1,000,000. It could be maybe 500K. It could be up to 65 million. So like it's infinite number. So you're going to see regression. We can use a classification for this. You picking classification or a regression depends on the data set. If you're trying to predict, will you get a job based on your qualification? So let's have a data set as maybe one of the data sets. So this will be like yes, no, yes, no, yes, no, and then we will have maybe experience this, and we're trying to find out would you get the job or not. So it's like a classification. It's either you're in boss A or in boss B. So it's either you're yes or no. Either you have cancer, either you like there's a class, like a class this then. So that goes to classification. So no, the regression is not to find the predictive power of your model. Was that okay?
So any other
People like,
question?
yeah.
If you have any other question, you can put it in the chat box. That's for Lawal. Okay. Lawal
Yeah.
said thank you. Lawal
You're
said
welcome.
thank you.
Yeah,
Okay.
you're welcome.
So any other question?
Okay, yes.
Okay. Question.
Yeah, so this is also use this. to get like details. So if I copy this link, covariance, paste it. Yeah. So you can see this to get details about the community.
Okay.
For the different categories, and anyone you click on, it links you to the YouTube channel. And if you click any links here, you also get to the YouTube channel. So you can also use this. And engage, probably bookmark it. Are there any other questions? Okay, even
Okay, someone else is up.
and that's thing again that I've also probably done again was I could have also normalize normalize our data set. As you can see, our area here is all the way to 74,220. Now these numbers are 4 to this, so like the numbers are very far. So normalization and standardization would have made everything to 0 point something, 0 point something, 0 point something, like give everything like a 11 grant. So that's another thing I've also done to improve this. But I'm just trying to build something simple, so I didn't go into so much details.
Okay. So Uzodimo is up now. Uzodimo. You can speak now.
Thank you so much for your time.
Okay. Yes, that's what I'm saying. So this data set is a absolute novice. That's why I picked a very basic. So there are some data sets that are very like standard. So like the housing data sets, the Titanic data sets. So these are like the data set everybody starts with. These are the first models everybody picked with. Usually the first model everybody starts with is you building a linear model or your classification, which is this. So like the ARIS data set, if you're trying to do computer vision, that's probably the first thing you will run, the ARIS data set. The housing data set, which this is the Boston housing data set, the ARIS data set, the Titanic data set. Titanic data is the first. Everybody that does machine learning have used these 3 data sets. So these data sets are like the basics of the basics. And they're all available here on Cargo. This, even when you sign up on Cargo, this is the first data set to introduce you to, or they'll tell you to take even that courses. This. So these are like basic elementary data sets. So everybody that have ever done machine learning has practiced these 3 data sets. So the data set is simple. As you can see, there's no cleaning to do. It's just you work in it. So it's simple. So this is like a very novice, simple. All the data sets are very simple and novice. If you go a bit more further, you see more complicated or more data set where you can practice your feature engineering, your how to fill missing gaps, how to fill missing values, how to fill missing values, but for the housing data sets, the Boston housing data set, the ARIS data set, and the Titanic, that are very simple and very elementary data sets. So this is actually very novice.
Okay. So Uzodimo, you can speak now.
Okay, so thank you so much for your time. So I want to know, is there a way we can know the features that are useful to the training of the model?
Yes, that's what I mentioned. On feature engineering. So you do a bit of feature engineering. So maybe feature will have a more another session will go into feature engineering. So that's what feature engineering. So feature engineering will determine just how so feature engineering will determine will tell us which of our features are more important and which of maybe are not, which of them do not really have so much influence, so we can drop those instead of us just random dropping the idea there. I would have done in feature engineering.
Okay.
So okay, thank you so much. Thank you.
So any other question? I think someone else was up before. Person has left. Okay. So any other question? So I'll be dropping the feedback form now in the group chat. So if anyone has any feedback, suggestion, anyone you think we might invite to, anyone you think you need us to invite to our section, just send it to us. You can help us fill the feedback form. Okay, so Lawal said something. He said, I find it quite striking that a simple demo here aligned with an article I read recently that a number of bedrooms is actually more relevant to a property price. So
like a general stuff or number of bathroom affects. I don't know if number of bathrooms affects property price.
Yeah, if like maybe like a big mansion now, you say like 3 bedrooms, like a jacuzzi and everything. So you know the price are usually higher than a single bedroom.
Okay. So that could be true, but it also varies city by city.
Yeah, that's true. So
City by city. Also varies city by city also.
Okay, so Chigozie said, "Good evening, and thank you for this class. Please, I'm getting into this field. On which platform do you think I can carry my analysis on?"
Okay, so is it where you can get data set, or is it where you can? Is it about where you can get data set, or is it more about where you can learn machine learning, or which is so that's which was the question exactly? If it's where you can learn machine learning.
So Chigozie, you can speak now. Yeah, presenter now, you can speak. Hello, Chigozie. Hi, Chigozie. Okay, Benny, you can continue.
Okay.
Hello.
So if hello.
Hello, can you hear me?
Yeah, I can hear you.
Yeah,
I can hear you. Yeah,
Okay, good evening, and thanks for the class. I appreciate so much. I'm just getting into the field, like I said before. Just like in programming, where we have the IDE, like VS Code for the programming thing. Yes. For this, I was following what you were doing, but I didn't know the platform where you were doing it.
Oh, okay. So, let me just give maybe more of a basics, I guess. Okay, so I use Jupyter. Okay, so most of the time, like for newbies, they'll tell you to use a notebook. There's nothing for you to use an IDM. You can go with a notebook. So for a notebook, you can use Jupyter notebook. So you can use Jupyter notebook. Jupyter notebook is very simple and the interface is good, and you can also work with it offline. So either they'll tell you to use Jupyter, or they might tell you. Some of them also recommend Google Colab. So Google Colab, but Google Colab is online. But as far as you have a Google account, you have access to Google Colab. Everybody has access to Google Colab, but it works online. Okay.
All right.
Then.
All right. Thank you.
All right.
So also Idowu, you can speak now. I think yours will be up. Idowu, you can mute yourself.
Okay. Yeah. Good evening, everyone.
Good evening.
I was going to ask if I want to start. I want to get into the field. How do I start learning? That's my basic question.
Oh, okay.
Because yeah, that's my question.
That's a question. Basically. Okay. So okay, so UrBizEdge also offers like Python for data analysis class. So you can use you can follow UrBizEdge. Another way, yes, the session is recorded. Another way you can also start again. You can also use Kaggle. So you can also have courses which you can follow and use. It was for data sets. Kaggle houses a lot of data sets. Also again, there's this other platform. I think UCI. Yeah, UCI education. Yeah, UCI education data sets. Yeah, UCI. Yeah, UCI. Yeah. They also has data sets. This is another place where you can get data sets. But you used to learn, you can use UrBizEdge, you can also use Kaggle. There's of course here.
Okay. Thank you. So you say I mean, but the problem is I prefer physical training than I don't know, maybe at least to start up with.
Okay.
I would like physical training than online platform.
Okay.
Also, I would like to know about, okay, I don't know about how to be able to use the Git or something to be able to showcase the kind of work that I've been able to do or something like that. But basically, I'd want something that is more physical than online.
Yeah, so that's what I'm saying. So it's physical. If you want physical, then UrBizEdge does physical training. You need to do physical training. So you can sign up for the physical class. UrBizEdge.
Your meal?
I sense no UrBizEdge. UrBizEdge.
Okay.
Yeah, so physical classes. UrBizEdge does physical classes. So you can contact them. Yeah, let me. Timothy will send the emails and everything. Then, so you asked the second question. I can't remember. You asked another question.
Yeah, about using Git.
Okay, using GitHub. Okay, using GitHub. Using GitHub will have to be a entire session. So maybe I'll take it down and we'll have another session. I think by next month. This on GitHub. So just follow up with you can follow up with if you have a community page where so you can get links of the topics that are coming up, and I'll make sure I do a session on GitHub.
Okay, thank you.
I'll do that. So GitHub. Okay, are there any other questions?
I'm fine, thank you. I'm fine.
Okay, you're welcome. Let me send the community link. Yeah, so if you join the group, you will get emails about the topic. So yeah, so there's a free space. So maybe I could do a session on this day on GitHub. That's in 2 weeks' time. Yeah, that's the closest date available. Yeah, so we'll have a session on GitHub maybe on February 6th. Are there any other questions?
Okay, so with no further questions, I think we'll be ending the section now. So thank you everyone for attending this section. So the next program session we'll be having is on Power BI
1 hour time.
by 6. Well, 1 hour time.
1 hour time.
So by 6, I'll be dropping the link to the section. So we're having best practice in Power BI for those that are interested by 6. So I just dropped the link. So this is the link. So you can join us by 6 p.m. just an hour time from now. So thank you everyone, and have a wonderful week ahead. So bye guys.
Bye.
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 Hi Grace.